We're going to take a look at asymptotes of secant and cosecant graphs without actually having the graph and after transformations have been performed. So the first one we're going to look at is we want to find the asymptotes in the first counterclockwise revolution, which is 0 to 2 pi, of f of x is equal to 3 secant of 3x. So the way that we begin that is we first look at the parent function. So the parent function, the basic function, would be y is equal to the secant of x. And we think about the asymptotes on this basic graph. So secant has the domain of all real numbers except odd multiples of pi over 2 because it cannot, cosine of x cannot be 0 because that would be the reciprocal of secant. So we have that the domain is all real numbers except odd multiples of pi over 2. Now, at the x's where secant is undefined, there are vertical asymptotes there. And so vertical asymptotes are vertical lines, so they are written in the form as x is equal to a constant c, which in this case would be odd multiples of pi over 2. So I'm going to write a few of them. X is equal to, and of course, because odd numbers go to infinity and negative infinity, secant has infinite amount of asymptotes. So I'll write a few in this direction. So it'll be negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, 5 pi over 2. And I mean, you can keep going as long as you would feel comfortable. I think that should be enough to just kind of see the behavior of what's going to happen. Now I want to take a look at my new function, which is y is equal to 3 secant of 3x. Now what's going to happen here is that this 3 in the front is a vertical stretch by a factor of 3. That's changing your y's. It will take your y's of your function and multiply them by a factor of 3, which means that it doesn't affect the x's at all. It's only affecting your y's, but your asymptotes are vertical asymptotes. They're x equals. So this actually does not affect the vertical asymptotes at all. Next, you want to look here, and this is the 3x, and this is going to be a horizontal shrink, and you're going to take your x's and shrink them by a factor of 3. So multiply all your x's by 1/3. Well, because your asymptotes are x equals, this is going to affect them. So what you're going to do is you're going to take all your asymptotes and multiply them by 1/3. So I'm going to have, and I'll negative 3 pi over 2 times 1/3, so the 3's are going to cancel. Then I'm going to have negative pi over 6. Then I'm going to have pi over 6. Then here the 3's will cancel out, so I'll have pi over 2. Then I'm going to have 5 pi over 6. Then I'm going to have 7 pi over 6. So all I'm doing is I'm multiplying all of these by 1/3. And of course, like we talked about, it's going to go to negative infinity and infinity. So what you want to look at, right, is just to get the ones in the interval that it's asking you to get them at, which is 0 to 2 pi. So immediately the negatives are out. So pi over 6 is good, pi over 2 is good, 5 pi over 6 is good, 7 pi over 6 is good. So I might have more. So if I draw a little diagram of what's happening here, right, I have the pi over 6, the pi over 2, the 5 pi over 6, the 7 pi over 6. So if you take a look, they're all equidistant apart from one another, right? So this is 60 degrees, this is 60 degrees, this is 60 degrees, right? So the next one is going to be 60 degrees away, which is going to be 3 pi over 2. And then it's going to be another 60 degrees away, which is going to be 11 pi over 6. And then, of course, if you do another 60 degrees, it would be greater than 2 pi. So I'm going to have x is equal to pi over 6, pi over 2, 5 pi over 6, 7 pi over 6, 3 pi over 2, and 11 pi over 6. And this is x equals because they're vertical asymptotes. And here they are. Now, if this whole 60 degrees was hard for you, you could have changed your radians to degrees. So this would have been 30, this would be 90, this would be 150, This would be 210, and maybe then it would have been easier for you to see that they're all 60 degrees apart, right? Because remember that when you graph, the asymptotes are always equidistant apart because of the period of the graph. Now, it's important to note that if I was asking for the asymptotes of f of x is equal to 3 tangent of 3x, it would have been the exact same answer. Because remember that secant and tangent, they have the same basic asymptotes. So actually, both of these, if you have the same transformations, will give you the same final asymptotes. Let's take a look at one more. We want to find the asymptotes of the given function from 0 to pi of f of x is equal to negative 2 cosecant of 4x. So this would be a good time if you feel like you understood the last one to pause and try it on your own and then check your answer. So the first thing we're going to do is we're going to start off with our basic function, which in this case is cosecant. And the domain of cosecant is all real numbers except where sign is 0, so multiples of pi. So my basic asymptotes, I'll write a few. Negative 2 pi, negative pi, 0, pi, 2 pi, 3 pi. And you can always keep going and writing more. And then I look at my new function, which is y is equal to negative 2 cosecant of 4x. And again, this in the front is going to be a vertical reflection and a vertical stretch, so it's only going to affect the y's, which is not going to change my asymptotes, but this little guy will. It's going to take all my x's and multiply them by 1/4 x, horizontal shrink. So now I need to take my old asymptotes and multiply them by 1/4 x. So I'm going to have negative 2 pi over 4, I'll simplify that in a second, negative pi over 4, 0, pi over 4, 2 pi over 4, 3 pi over 4, and so on. So I'm going to get negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2, 3 pi over 4, and now I want to look at the ones that are in my interval that I'm being asked. So in this one it's 0 to pi, including 0 but not including pi if they're asymptotes. So these ones are gone because they're negative. So I want to include this, I want to include this, I want to include this, and then I want to see, okay, well, this is one of the asymptotes, this is one. So they're all 45 degrees apart. So the next one would be at pi, but I don't want to include pi, so that one's out. So actually here are my 4 asymptotes. X is equal to 0, pi over 4, pi over 2, and 3 pi over 4. So in my graph, I would have asymptotes every 45 degrees apart, but from 0 to pi, I would have these 4 specific ones. And then it's important to note that if I would have been asked y is equal to negative 2 cotangent of 4x, it would have been the same. Because again, cotangent and cosecant have the same basic asymptotes.